This is the second part of graphing quadratic functions when a is not equal to 1. So just to recap, we looked at the different values of a, some different values of a, and how it affected the graph of the parabola. So again, the bottom line here, and I'm going to go on to a new page, so I'm going to move my graph over to the side also. So the bottom line here is that the A will cause a stretch or shrink to the height of a parabola. So the A will cause a stretch or shrink to the height of a parabola. All right? So basically the deal is that when A is bigger than 1, so when A was larger than 1, our parabola was stretched out, which made it taller and skinnier. So that is a stretch, and it was tall and thin. All right, when A was less than 1, but it's still bigger than 0, okay? So when it was smaller than 1 but above 0, so a fraction like 1/2, that was a shrink because it was, let's say, I guess we would say it is wider. I don't know. Do we say shorter? I don't know. Shorter, wider? I think wider sounds good. And then if A is less than 0, that's when our A is negative. That is going to cause a reflection. So it's going to reflect, which means that our parabola is going to open downwards. I hope that makes sense to you guys. So a negative A value is going to cause our parabola to look something like that. All right. And then if we have a negative that's a fraction, it's going to go down, but it's going to be wider, and that's what we're going to work on now. All right, so here we go. Let's go with, let's see, we stopped with example 5, so let's start with example 6. All right, so let's say y equals 2 parentheses x plus 1 squared minus 3. All right, I'm just making this up. All right, so I'm going to get a piece of graph paper here. So first thing that we need to do is locate the vertex and the axis of symmetry. So this right here is in vertex form. So since it's in vertex form, I can look right here to get my vertex. So the vertex of this parabola is going to be at -1, -3. So again, I am just looking, sorry, felt like I needed to focus a little bit. Looking right here for the vertex. So -1, -3. And then we know the axis symmetry is a vertical line that's going through -1. So the axis symmetry is x equals -1. All right. Now, I also know that the A value is 2, which means that this parabola is going to be 2 times taller than a normal parabola. All right, so here we go. So let's go over to the graph paper, and I need -1, -3 for my, so I'm going to set my x-axis right here, whoops, and my y-axis right here. Okay. All right, so the vertex is -1, -3. So -1, -3 is right there, if I did that correctly. All right, I know that the axis of symmetry is a vertical line. It's imaginary, that's why I'm making it dashed. All right, And now I know if I was doing a normal parabola, I would go over 1, up 1, over 2, up 4, over 3, up 9. But I'm not doing a normal parabola. I'm doing a parabola that's 2 times taller. So instead of going over 1 and up 1, I'm going to go over 1 and up 2. Instead of going over 2 and up 4, I need to go over 2 and up 8. And that's all that I can fit on this graph. So I know that I have mirror image points for these. And now I can sketch, or attempt to sketch. There we go. There's our parabola. So this equation right here tells me that the vertex was at -1, -3, and that the parabola was 2 times taller. It was a stretch of 2. So that means our parabola is taller and thinner than the normal parent parabola. All right, let's try another one. Let's see, move that over there. For example 7, all right, what if we did y equals, let's do -1/2 x minus 3 and x plus 5. All right, this one is in intercept form. So first thing we need to do is identify the vertex and the axis of symmetry. All right, so in figuring out the vertex, we know that this x-intercept is 3. This one is at -5. So if I average these together or figure out where the middle is, I am getting -1. So now what we need to do is fill in -1 in here. So if we fill in -1 right here, so I'll write this out so that you can follow what I'm doing. So -1 in here would be -4, and -1 in here would be +4. And if I multiply all of that together, I think I'm getting 8. So if you need to pause and think about that. So now we know that the axis of symmetry is a vertical line going through the x value of the vertex. So the axis of symmetry is at x equals -1. And then I know that my a value is not 1. My a value is -1/2. So what this means to me is that my parabola is going to open down and it's going to shrink and be half of the normal size. So actually, let me say half as tall. All right, so here we go. Let's get a piece of graph paper here. And the vertex is -1/8, so I need more on the top than on the bottom. So I'm going to set my x-axis and y-axis like this. All right, our vertex is -1/8. I know that I have an axis of symmetry right through here. All right, so now I need to start thinking about my parabola. So my a value is -1/2. So if this was a normal parabola, I would go over 1, up 1. But it's not normal. It's half the size and it's reflected. So instead of going over 1 and up 1, I'm going to go over 1 and down 1/2. All right, a normal parabola would go over 2 and up 4, but this one's not normal. So I need to go over 2 and I need to go down. Instead of going over 2 and up 4, I need to go over 2 and down 2. All right, a normal parabola would go over 3 and up 9. This one's going to go over 3 and down 4.5. And I can probably fit my other one, but that's all right. Oh, you know what? Never mind. I do want to do this so I can show you this. This is so cool. This is like a one-time happening thing. Okay, so normal parabola would go over 4 and up 16 because 4 squared 16. So over 4, up 16. This one's going to go over 4, and instead of going up, it's going to go down. And instead of going 16, it's going to go 8, which is right here. All right, so I know that because this is an axis symmetry, I have mirror image points over here, here, there, and there. So now we have a good idea of where this parabola is located. There it is right there. But now here's what I want to point out. Remember these two numbers we got up here? There they are. Here is yikes. Here is -5, and here is +3. So this is called intercept form because when we solve for a parabola, what we're doing is we're finding where it hits the x-axis. So this one hits the x-axis at 3 and -5. Halfway in the middle is where the axis of symmetry and the vertex are located. And then, because of this right here, our parabola is going to go down instead of up, and it's going to be half the height of a normal parabola. So that's a lot to soak in, but I'm hoping that you are following that. So just to kind of go through your steps, I'm going to go to a new sheet of paper to just kind of lay this out here. So I'm going to say that here are your steps to graphing. Steps to graphing. All right, so first thing, you have to find the vertex. Absolutely find the vertex and the axis of symmetry. And by now, hopefully you guys are amazing at that. Those are the two things that are going to kind of anchor your parabola onto the graph. All right. Now, the next thing is to identify the A. All right, now, the deal is that we mentioned this just a few minutes ago, that depending on what your A is, if it's bigger than 1, it's going to stretch and be taller and thinner. If it's between 0 and 1, it's going to shrink and be wider. If it's less than 0, which means it's negative, it's going to reflect, and it might reflect and stretch, or reflect and shrink. So it could be both of those things. All right, then you're going to set up your graph. You're going to graph your vertex and axis of symmetry. And then you want to graph as many points as will fit. Graph as many points as will fit. And again, you're basing it off of what a normal parabola will do. Okay, as always, if you need to go back and rewatch anything or redo the examples, please do, because the purpose of the video is for you to learn and understand how we graph quadratic functions, and this one was when the a value was not 1.